Recognising the need to use method 4 should be fairly easy, in that in the equation, in the trig equation, you'll see that there is a trig ratio in the denominator, possibly, or trig ratios being raised to a power. And if you look at this example, you'll see what I mean. So clearly there's a trig ratio in the denominator. It's quite a complicated expression making up part of the equation, in that there are actually two terms involving trig ratios. The nice thing about it is that these are both the same trig ratio, and that is also a feature of to recognise, so that you identify that you need to use method 4. So same trig ratios, trig ratio appearing in the denominator, all looking a little bit complicated. What's nice about this example is, though, that the equation is equal to 0. Now, we've said we're going to use substitution. The substitution we use is similar to previously, in that we use the letter U, but that's it. We're totally substituting for all of the trig ratio. So not just the angle, not just that part, but the whole of cos theta is going to be U. We know, before we get started, we know that cos of x cannot equal 0, because that would make the whole equation undefined. Therefore, if at any time we're suggesting a solution that U is 0, then we have to say that is not a solution, because U now can never be 0. Let's substitute it into this equation and see how it looks. So it's going to look like that. Now, hopefully you would look at that and say, well, if this was just an algebraic equation, I would remove the U from the denominator by multiplying throughout by U. So multiply that first term by U and you get 4 minus U squared. Multiply anything by 0 and you keep 0. Now, you have, as the notes say here, you've created an algebraic equation that we're able to solve, and yes, because it's a quadratic, there will be multiple answers. So 4 minus U squared is equal to 0. What do you recognise that as, and how did we solve quadratic equations previously? We solved them by factorising. And we can see that this is the difference of two perfect squares, which will factorise to 2 minus U and 2 plus U, which is equal to 0. Now, I don't know if you can see this, but I can see this. I've probably had a typo in that, setting up that equation, because now we know that 2 minus U could possibly be equal to 0. That is, U is equal to 2, but U is cos of x, and what do we know about the cos graph? It never gets up to 2, therefore no solution. Likewise, 2 plus U is equal to 0, U is equal to minus 2 is also no solution. So unfortunately, there were no solutions, and this didn't feature either, which I thought it might, and it could in some of them, where you factorise and take U out and put it equal to 0, and then you have to realise that you have to say there's no solution. I'm really seriously thinking that maybe that's a total typing error on my part, and it should have possibly been a 1 over cos of x. Then we would have got some solutions, because cos of x can equal 1. Never mind. I'll stop the video there, and hopefully you will recognise the situations where you need to use method 4.